Phone, and I'm the president of SSA New South Wales branch. On behalf of the branch, I thank you everyone for joining us for this year's Lancaster Lecture. We'll begin the formal part of the evening with acknowledgement of the country. I'd like to acknowledge and pay respects to the traditional owners of the land on which we meet, the Gadigal people of the Eora Nation. As we share our knowledge, teaching, learning, and research practices within this university, may we also pay respect to the knowledge embedded forever within the Aboriginal custodianship of the country. And it's my absolute honor to introduce tonight's speaker, Professor Adrian Barnett from QUT. Adrian has over 21 years of experience in analyzing medical data, during which time he has worked on trials, longitudinal data, case control studies, and cohort studies. He also co-authored 2 statistical textbooks with Professor Annette Dobson, most notably a popular book on generalized linear models. Adrian just finished his term as a national president of the society last year. And his current research is focused on meta research, which uses research to investigate research with the goal of improving research practices. Tonight, Adrian will talk about best statistics in health and medical research. And may everyone join us to give Adrian a warm welcome for his Lancaster lecture.
Thank you, Thomas.
I think
Yep. Oh. Got a microphone. Hello, Sydney. So I've actually done similar talks in the past. So if you have heard this talk, well, actually, don't worry, because it's totally new content. You can get new content for a talk like this easily in a month if you try hard in a week, because this stuff just keeps coming up, I'm afraid to say. Sorry, pressed F11 and then. Oh, there we go, finally found every button. So I work on up in Brisbane on the lands of the Turrbal and Yuggera people, and I'd like to acknowledge them today. And QUT acknowledges that the Turrbal and Yuggera people as the traditional owners of the lands where QUT stands, and pay respect to their elders, customs and creation spirits, and recognise that these lands have always been places of teaching, research and learning, and recognise that terra nullius was a complete lie. And it's an honour to give this lecture for Henry Oliver Lancaster. I didn't actually know that much about him, so I read an interesting paper about him, and what a great thing he did was to co-found the Stats Society of Australia, and I'm sure he'll be very proud to see all you guys here and see how healthily the society is going. And there was a nice little anecdote in amongst a paper about his life, where he met Prince Philip, HRH, and HRH, when he found out he was a statistician, came out with that classic lies, damn lies and statistics, and HOL, as apparently Henry Oliver Lancaster you'd like to be known, quickly got in there with figures fool when fools figure. So good for him. One of those statements is true, and only one. Okay, this talk in a nutshell, with the emphasis on nut. Quality is in the background. Fauci is in the background. Quantity is what's ruling the roost. And a bit like with Trump, Trump thinks that he's quality. He doesn't recognize that he's just big quantity. So we have, just talking with Nick before, the classic one is league tables. People think these are measures of quality, and they're not, and they drive terrible behavior in universities, terrible decision-making by researchers. And I've actually spoken to senior university people about these league tables, pointing out how just statistically rubbish they are. The idea that you can summarize a university into one number just makes absolutely no sense. And they all say, oh yes, Adrian, we know, but they still just play along because they have to, because everybody does. I think there's like 2 universities in the US that have actively disengaged from league tables. That's a pretty pathetic number when you think about the amount of universities in the world that have worked out that these things are rubbish. So quantity is in charge. Quantity is driving everything in our research world, and quality, like Anthony Fauci was during the pandemic, is having a hard time, but we've got to stick up for quality. And look at this boom in quantities. This is from PubMed. You know, back in 1990, we had about 400,000 papers uploaded to PubMed a year. We're now up to 1.6 million. This curve looks so steep, it looks like it's going to fall back on itself. I mean, this rate of increase, and I mean, that includes some of the pandemic stuff, but even with that, it's just crazy. We can't keep up with this amount of stuff. And crazy things are happening where you have multiple areas now where there are more systematic reviews than there are original papers. So somebody will look at a research question. And this happens a lot. And I'll get onto this again later. And one reason is systematic reviews are a relatively easy study to do. Yeah, you don't need ethics, you don't need, so people, I need to publish a paper. Let's do a systematic review on X. So you can have areas where there are 20 systematic reviews with 10 original papers. Even more embarrassingly, sometimes those systematic reviews don't agree. And what's happening, I think the general trend is, maybe I've got the slope slightly wrong there, put a bit of a confidence interval around that, but I think the problem is, as this quantity is going up, quality is going down relatively severely. That's not saying that the past was a golden age. There were problems then too, but I think they're becoming much worse now. And what I've really noticed is, as a statistician, you know, you work in a lot of areas, you get to see a lot of papers, and you get to see a lot of the way different fields work. And something I've really noticed, I've started to call them research-shaped objects, okay? They look like a paper. People know how to create something that looks like a paper. It has the vestiges of a paper. There's an abstract, there's a methods, there's an introduction, there's my conclusion, there's my table 1 with the baseline characteristics. Here's my univariate analysis. Here's my multivariate analysis. Tick, 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 tick. But when you poke or when you taste these papers, they're really terrible. You know, when you ask questions about the paper, people either just disappear or, you know, heaven forbid if you ask people, can I have a look at your data? Can you share your data? I mean, people just run for the hills. And I think I really like this word, abetting. So this comes from the cargo cult paper in Significance by Stark. Bad statistics is abetting weak science. I really like that word because it's for me, it has that criminal connotation. Our field is being used to support really rubbish research. And people are using statistics to support their rubbish research because it gives that sheen, that halo effect. Oh, there are numbers, it must be right. And then with Nicole White at QUT, we've been looking at what do people write in the statistics section? And you'll be amazed the number of statistics sections that are just this. Two-tailed t-tests will be performed with a p-value of 0.05 indicating significance. Sorry, sometimes they have the word significance. Sometimes they hyphenate p-value. Whoa, those crazy hyphenators. Sometimes p's in capitals. Apart from that, you can find thousands of stat sections that are like that. What's actually done in the methods, or in the results rather, doesn't seem to have any correlation with this. And the other classic one, which we see a lot of, is all statistical analysis was performed using the GraphPad Prism software. So I used clever software, therefore I didn't need to do any thinking. The computer did all the thinking for me. But you know, this has been a problem for a while. I mean, Doug Altman, I didn't put the year on that quote, but I'm pretty sure it's from the 90s. He said, many people think that all you need to do statistics is a computer and appropriate software. And I do see that idea a lot. You crank the handle, data comes in, crank the handle, results come out. Tick, give me that publication, I need it. And it gets really bad. So I'm going to present, I put this on Twitter. I think I've found the worst ever statistical methods section. I'm going to reveal it to you all now. So this is a paper from the Winter Olympics. So this is somebody, you know, they've won a gold medal. They've spent 5 years of their life or more working on their dream, and it's come to reality. And, you know, it's a beautiful photo. What I'm going to show you is people doing the reverse. They've spent about 2 seconds on this work. So in bronze medal position, t-test. That was it. That was the stats method section. Now, this doesn't come from a peer review paper. This comes from the Australian New Zealand Clinical Trials Registry. So on there, there's a section in there for where you're supposed to write what you're doing in your stats section. Okay. So it's not peer review, but it is looked at by somebody, and you are supposed to put in there what you're going to do. So the idea of you can just write t-test is just frankly ridiculous, not even independent or what the outcome is or anything, just t-test, that's it. That's bronze medal. There are two worse. Here we go. Second place, SBSS. That was it. There were a couple of others that were SBSS Chicago, SBSS version, you know, version number. What could be worse than that? SSPS. Somebody wrote that. Maybe SBSS does need more S's and less P's. Maybe they're trying to give us some messages there. And I would say this is another advantage of using R, because it's quite hard to get that wrong. Although maybe some people would even be able to manage that. I mean, this just really, you know, it's funny, but at the same time, it just shows a sort of utter contempt for this part of their experiment. And these are for clinical trials. So I'm like, well, it makes me wonder, why are you guys doing this clinical trial? You're going to collect all this data. You're going to, you know, collect data from patients possibly, or animals, or do all sorts of things. And then you're going to waste all that by just doing something half-assed in SBSS. There is a better one. So this is actually published on PubMed, and Daniela Witten found this. It's a bit small, but I think you can see in the results section, it says, insert statistical methods here. So, and these are the ones being caught, you know, I think, and there have been other cases, just chatting with Alex and Sabine earlier, there have been other cases where people have accidentally left comments in papers that have ended up being published, which is very funny. But that one's pretty funny. That's just the tip of the iceberg. I think there are lots of other people, you know, not giving proper thought to the statistics up front and doing it all right at the end. Okay, there's a lot of terrible practice. I'll just go through some numbers. Regression, which is one of, I mean, regression is, you know, the scalpel of statistics, I would say. It's the technique that is so useful. I use it all the time, because it's a really handy technique. If you do it well, you can find out stuff about your data. But when people look at the literature, I mean, this paper found only 22% of papers in medical journals reported checks of the regression model assumptions. So, you know, who knows what's going on? You've got some parameters there. You've got an association, but you haven't checked linearity. It could be completely wrong. 92% of all papers using linear regression were unclear about their assumption checks. Sample size, studies that explain their sample size. These guys did a sort of review of it. 0% in some fields, 17% is the high. That's pretty terrible. And then figures, and this was done by a group at the BMJ, including Doug Altman, and they looked at a whole load of figures qualitatively and found that less than half of figures met their data presentation potential. And again, that's a real waste. Like a good figure can be one of the most interesting things about a paper, can be the thing that makes me change my mind about something, that makes me think it's really there. So it's very sad that people spend all this time collecting data and then really make a mess of it. And then I stumbled across this plot, which I think it's a real achievement that they published this, because I think they've actually got almost every single problem that you could think of. I mean, let's start out. And I wasn't looking for bad plots. I was actually interested in their data because it was on student evaluations. There are no labels in there. I have no idea what any of these pies are. Also, they're pies. That's bad for a start. The numbers don't add up to 100. That one in the top right, it's not even close, 96.16. You can't see some of the numbers. I mean, that one they put outside the circle, so you can at least kind of see it, the 33.87. But they've got, you know, moire patterns everywhere. This one's lovely, you know, black on a purple background. Terrible. That circle's smaller than that one. Is there a reason for that? I don't know. Did you just get bored? Yeah. Oh, and then totally unnecessary decimal places as well, everywhere. This is really, really rubbish. But I see a lot of figures that are really bad. And the amount of times I see 3D pie charts as well, it's just, you know, we know they don't work. We know they misrepresent data. They're been well shown to do that in experiments. Just stop using them. And then with the student, you know, we're just actually reading a whole load of papers, and I just picked out some of my favorite sentences. And this is something you see a lot. I can't remember, somebody else I think coined this phrase, a smoothing syndrome. And what they did was outliers were removed when the residual had a student odds residual of less than -4 or 4. Okay, just get rid of that. That data doesn't fit our ideas, out the window, you know. But it looks kind of good, you know. Hey, we used the student odds residual, and we had a symmetric threshold. That's sciencey, yeah. Like, no, it's not sciencey just to throw out data that you don't like the look of. And there's an even better one, and I have tweeted about this before, and this one got quite a lot of coverage. But I mean, this is what they said in their results. We continuously increased the number of animals until statistical significance was reached to support our conclusions. And when I tweeted that, a lot of people said, so there was a bunch of people who said, oops, they said the bit you're supposed to say quietly out loud. But there were actually, and I tried to engage with these people, a number of other people who were like, I don't understand what's wrong with that. So, you know, this bad practice has become normal practice for a lot of people. And the reason you don't throw out big residuals, the reason you do look at residual plots is because sometimes they can be the most interesting thing. And this is Isaac Asimov, who is a scientist and a science fiction writer. He said the most exciting phrase to hear in science, the one that heralds new discoveries, is not eureka, but that's funny. And I think that's really true. Like the times I've been doing something and the slope is in totally the opposite direction. Sometimes you find that's because you've coded yes as no and no as yes, yeah? But you fix that before you publish it. But there are other times you check all the code and everything is in the opposite direction. And that is normally the time when something actually really interesting is happening. It will make it so much harder to get it published, that's for sure. But the science is so much more interesting. And I mean, I remember once that we had this analysis of women's careers, and we asked about 100 women if they'd had a baby, and then so we looked at their publishing status over time and the timing of their children. And I said to my colleague, oh, let's do a leave one out analysis. So we left every woman out and redid the analysis, and the slopes were all over the place. There were massive influential observations. And I thought that was so fascinating because it meant that these associations that we see were driven by a couple of very high-performing women. What an interesting result. Oh my God, it was so hard to get that published because it wasn't a nice, neat, wrapped in a package result. There was something odd going on that we couldn't quite explain. Another thing that I think is a really, and it's a kind of a hidden issue actually, and so this is some stuff that Brian Nosek and his group did to kind of uncover this. So it's called researcher degrees of freedom. It's the things that we can do behind the scenes that don't end up in the final paper, but that actually can end up having a massive impact on the analysis, because we make choices all the time about what sort of analysis we're going to use. And what they did was they got a data set, a big data set of footballers, and they had their skin tone, and then whether they were sent off or not. So if you get sent off, in case you really don't know, if you get sent off, that's a bad thing. And the referee chooses who to send off. So there's a potential for racism to come in there, that referees will send off black players more. And this is one of my favorite ever players as well, Adebayo Akinfenwa, getting sent off. So what they did was they gave the exact same data set with the exact same research question to a whole different bunch of researchers who all independently had a look at what the analysis was going to be. And here's the results in a kind of forest plot thing. And in a way, it's maybe actually not too bad, because you can see there are actually quite a few research groups who get a reasonably similar answer. kind of suspiciously that the lower confidence interval is just above the threshold for significance, but let's pretend that's just an accident. But you do get people who come up with, you know, a couple of research groups that come up with substantially different results. So, I mean, these two here seem to be indicating absolutely no effect. There's no racism. Whereas the majority of the other papers indicate that there is certainly some effect. And then a couple of papers that seem to think there's a very strong effect. So when we're looking at obviously published papers, we've got no idea. You know, sometimes we've got no idea what we're looking at. And of course, the other terrible thing that happens is these ones here are often the ones that grab the headlines, the crazy, wacky, far out result. And then they don't replicate because they're a crazy result, possibly because the researchers chose the wrong method or chose to, we excluded all outliers where maybe they used -3 instead of -4. So that was okay. There's also, of course, this enormous pressure for good results, the results that are going to get published. And this is an interesting study where they asked US statisticians, you know, what sort of requests have you had in the last 5 years? And there was a whole bunch of things. And so 24% said, yes, somebody has requested that I remove or alter data to better support the research hypothesis. 24% said they'd been requested not to report the presence of key missing data that might bias the results. And then 29% were told to or asked to ignore violations of assumptions that would change results from positive to negative. And I mean, if you've ever been a consulting statistician, I'm sure you've experienced this too, you know, when the results are not quite there. And sometimes it's done in a pseudo-scientific way. Sometimes it's just blatantly, oh, we should just get rid of those. But people will find reasons to get rid of data to support their ideas. And a technique I've tried to use lately, though it's not perfect, but it does help, is now, particularly if there's anything controversial, but when I give results to people now, I initially give them a scramble analysis. So if there's a main treatment, I randomize that treatment, create a whole new variable. And of course, with our markdown, it's really easy. I give them the final report that's going to look exactly like the final report, but it's all nonsense. Well, the data is real, but the treatment effect cannot be real. So don't interpret any p-values. Actually, one of the most interesting teaching moments I had was when a p-value was under 0.05. And they were like, but it's a random treatment. I'm like, yeah, you might want to think about that. It does help, but would you believe it or not, people still, and then I say, okay, you know, we're finalizing the results now, but people still ask for changes after they've seen the real results. And sometimes I put up a fight and sometimes I'm just too tired and I just do it because it's easier. Sometimes I am no angel in this area. I've made quite a lot of mistakes too. Maybe that means I'm the poacher turned gamekeeper. And then this is a very interesting plot. So all this filtering, all this reanalysis, all this research degrees of freedom ends up with crazy results like this. So this is actually data that me and a colleague collected, and somebody else did a much better plot with it. So we got about 900, I think it was close to 1 million confidence intervals from PubMed abstracts. So we just sucked them out. And we plotted the confidence interval to show this incredible rise in confidence intervals at the statistical significant boundary. All this person did was turn the confidence intervals into a Z value and came up with this histogram. And it's just bonkers, isn't it? I mean, you can just see where people are just striving to get, people prefer positive statistical significance is an interesting result of this. But you can just see there's this huge gap here. That gap is just not believable. When I see graphs like this, it just totally undermines my confidence in everything, almost everything I see in the literature. The one benefit it has is that it makes me think, Adrian, you need to stay healthy, because if you end up getting some treatment, who knows if it's going to be evidence-based or not. And the other thing that I think about with p-values as well, that I've really noticed, and another word, a fancy word I really like, is defenestrated. Because what I've noticed is when you're in a meeting room and you show people results, they look at the p-value and everything else gets defenestrated. Everything else gets chucked out the window. The p-value rules everything. And it shouldn't be. And then Kareem Carr, who's very worth following on Twitter, he just colored in that area and called it dark statistics, the mystery of dark statistics, like dark matter. We know it's like dark matter. We know it's out there. This graph shows it's out there. There's all these studies, millions and millions of studies missing from the literature. But there's at the heart of this is a really interesting graph from PLOS biology. Bad practice gives good results. So here's, if you've heard of registered reports. So registered reports are a way to try and stop this kind of p-hacking and reanalyzing. You state up front everything you're going to do in a registered report, and then you do it, and then you report what you've done. Okay? Called registered reports. There's another name for it, it's called science. Yeah, the way we were taught to do experiments. You run an experiment, you look at the results, you reevaluate. That was the way I was taught to do science. So it just seems to me like doing what we should be doing anyway. Here's the percent of null findings on the y-axis. And you can see the different types of registered reports here. That's an unfortunate acronym to call it RRs. You know, we've got sort of 60%, between 60 and 70%. So in these papers where they did a registered report, where they specified what they were going to do, most of those papers end with a null or negative result. And I actually think probably the percent is higher than that because, especially in medicine, most stuff doesn't work. We don't know why, because humans are complicated is the main reason. Then when you look at the traditional literature, the red dot down here, 10% have null findings. That gap is just enormous, absolutely enormous. And again, just not believable. But those papers get published and people's careers move on. We have terrible, terrible incentives. So this is some work that Paulie Stellick from Bond has done. A lot of medical colleges in Australia, they have requirements in there where you have to do research. So if you want to progress in the College of Surgeons, College of Anaesthetists, or College of Obstetricians or whatever, you have to do research. And what they do is they don't want to bother checking if that research is any good, because they can't. So the way they check it's good is, well, it got published in the journal, then it's good. So all these doctors want to do research. Oh, and the other thing they do, a lot of them say, well, you have to lead the research because you're excellent. You're a very famous, fantastic doctor. You can't be a junior researcher. You have to be the primary researcher. So all these researchers all these doctors try and do these studies that have no experience, end up producing a lot of pretty bad research, but they just have to get it published. That's why some of them do the systematic reviews. So that's a terrible incentive from these colleges. It's great to get doctors involved in research, but don't do it that way. Allow them to be the more junior researcher in a bigger project, things like that. So we are working with the colleges to try and fix that. And then, of course, I mean, beyond that, we've got daft rewards like money and promotions based on publication counts. And there's a paper in Nature just today, actually, with Jennifer Byrne, some quotes from Jennifer Byrne from Sydney, talking about these paper mills. You know, so these are companies now, mostly in China, it seems, where you can pay for somebody to make up a paper for you. And people are buying them because they get cash themselves and they get promotion. But then we've got this terrible rubbish in the literature. And Australia, well, are we doing well? No, I don't think so, really. I can't see us taking any action in this. We don't lead in this area at all. And we've got a terrible shortage of people qualified in maths. Less than 1 in 4 Australians in year 7 to 10 have a qualified maths teacher. 7% of girls took advanced maths in 2017 compared to 12% of boys. And that number is, it's not going up at all. In fact, I think if anything, it's going down, isn't it? And we've got the gutting of maths and stats at Murdoch's going on, threatened closure of the ANU Statistical Consulting Unit. So we're not taking these issues seriously here. I don't think this pipeline problem is going to carry on. Plenty of support for good statistics. Andrew Gelman's worth reading. The NHMRC are getting on board. They've written this report saying how important statistics is and another good and competence in research. And then myself and people like Ian and Jess and Margarita And John Carlin wrote a paper for the MJA about how important stats is and it's underfunded. I mean, every area of research says it's underfunded, but I think ours is one area that we can really make that case. And then I saw that somebody had cited this paper. And I thought, oh, that's interesting. I'll have a look what they said. And honest to goodness, here's the citation. P-value is considered significant when its value is equal or less than 0.05. I don't know how they got that from our paper. We didn't even mention p-values. I think they're actually trolling us. I think they're actually just saying, we don't care what you say, we're just going to carry on and we're going to cite you when we do it as well. There are some people who give me a bit of hope. This is Chelsea Parlett, who is really funny and does really funny tweets. She's very much worth following. There's her live footage of me explaining that the assumption of normality applies to the residuals, not the raw data. I've had lots of conversations where with exactly that same expression with me and the scientists. And this one really made me laugh. All models are wrong, but at least some are not stepwise regression. That's very funny. Okay, final thing I want to talk about. What I've been trying to build up to is we've got this huge issue with people who don't understand statistics, but we've also got a really terrible shortage of statisticians. And automation is not something I would have thought of a while ago. I've been watching it and looking at it, but I think it's getting more interesting. So I think there's a possibility for us to maybe automate some of our statistical knowledge and be kind of hidden in the machine like this guy is here. Maybe people don't want to talk to statisticians, but maybe if a robot told them your paper's rubbish, they might actually take some action. And one reason, this is a paper just published last month in PLOS Biology. These guys were actually able to automate quite a lot of stuff. So this is, you know, that by reading in inverted commas a paper, just with some very big, long algorithms, they actually got pretty good sensitivity and specificity. I think for everything but code sharing, sensitivity and specificity were above 90% to work out things like, was there a data sharing statement? Did they mention their funding? Was there a conflict of interest statement? What are some of the other things? Was there a protocol registration? Right? And you can see data sharing is going up a little bit. Code sharing is absolutely flatlining. So it's going nowhere, which is very sad because if you share your code, people, if somebody says t-test, if that's their stats method section, if they've shared their code, I can actually work out what kind of t-test, yeah? So I think this is kind of interesting, the idea that we can maybe read papers and give feedback to authors and what might we be able to check? And I have no idea whether this would actually work, but I know that we can check, and there are already algorithms that will check simple numerical errors. Somebody says 10 divided by 20, 55%. We can flag that and we can say back to the authors, check this, but this is clearly a mistake. P-values and confidence intervals, we can check that. You can check if the point estimate is outside the confidence intervals. It happens, unfortunately, quite a lot, but that's easily checkable, fixable when people submit these papers to journals. I think we should be able to check sample size calculations as well. If people, we should be able to find where the sample size section is and try and recreate their sample size calculation. And if we can't recreate it, let's see if journals will email these people back and say your sample size calculation needs fixing. Linear logistic regression models, I think the best thing we can hope for here is maybe being able to check, look, you haven't mentioned these things. You've used linear regression, but you haven't mentioned any of this stuff. Missing data, maybe we can check denominators, and if people's denominators are all over the place, but there's no mention of missing data, hey, it looks like you've got some missing data here. The other thing I think, and this might have already been done, but maybe it just needs to be ramped up, fraud as well, which I haven't really talked about too much. There are people who, well, apart from the paper mills, when people use fraud and when people make up data, they're not very good at it. They tend to make up data that, well, some of it doesn't have enough zeros in it. I think that's the digit people miss. But also, if they use trials, they make up treatment groups where the baseline data is just too similar. And we can detect that. And people have been caught by hand doing this way. Should be pretty easy to automate this when this stuff gets submitted to journals. I think there's a whole load of things we can check. I've gone automating crazy. People can talk me out of this, but it feels like a potential solution to me. Outcome switching. So people run a protocol and say, this drug will lower your systolic blood pressure and That's what we're putting all our eggs on. And then it comes to you see it in the news, and it's got miracle new drug reduces systolic blood pressure. And so, well, hang on, you said diastolic. People do this all the time. They move the goalposts again to get these big flashy papers. That should be able to be automated. Qualitative guidance on interpreting p-values. So when people get a p-value wrong, there are actually quite a few different ways they get it wrong, but they do tend to use common text. I think that's detectable. Poorly designed figures. I'm pretty sure I can write some code that will detect a 3D pie chart. Because you'll have that shade and then the lower shade. And I want to work for a journal that will just automatically reject all those papers. Citation manipulation, so that's where that's also apparently detectable. So that's where reviewers ask for unwarranted citations to their work. And then another very easy one, there's a whole load of retracted papers that are available on the Retraction Watch database. If somebody cited a retracted paper, just let them know at the review stage. Hey guys, did you realize, maybe they did that deliberately, maybe they were talking about that paper or how bad it was, but maybe they didn't. Because removing bad papers once they're published is very hard. And there are people there are people where everybody knows this is fraud. And even sometimes the person's been convicted of fraud, but the journal still won't retract the papers. And people will spend years trying to get this stuff out. And it matters because this stuff can end up in clinical guidelines. Once it's in PubMed and once it's started to get used, people don't check this stuff. So it can infect what would have been a lovely cup of tea. So I'm almost done. I think this is maybe a bit of an understatement. I think we need to change the conversation about statistics and health and medical research. And I think statisticians need to take back the conversation. We're not in charge of this conversation anymore. It's gone outside of us. There's so few journals that actually use a statistical review. And some journals, maybe the premier medical journal in Australia, like the reviews I've had from them on statistics have been absolutely gobsmackingly dumb. And that's really depressing. A couple of quotes to end. Most scientists today are devoid of ideas, full of fear, intent on producing some paltry results so they can contribute to the flood of inane papers that now constitute scientific progress in many areas. Here's a man, Paul Feyerbrand. He was willing to say what he thought. But he said that in 1975. So this has been an ongoing problem. It's just ramping up now. But then this gives me a bit of, this is the NHMRC CEO, Han Kelso in 2019. Poor quality publications won't change the world. They won't add to knowledge. They won't lead to improvements in the length or quality of our lives. There's Anne there. So I think I'm hopeful that there is a bit more recognition of these issues. The last slide to end on, we did well getting through without somebody. So my PhD student, Lee, is looking at these issues, and I think we just need 2 or 3 more reviewers now to do only about 5 papers each. So we just want you to go through a paper and sort of mark where they have checked linear regression assumptions and where they haven't, and if they've checked them, if they've done them right. So no actual financial reward, but you'll be contributing to an awesome PhD. Thank you, guys.
Thank you, Adrian, for a wonderful and, well, sometimes hilarious talk, and also give us a great insight on how bad statistics can do in some publications. Before we go on, let me oops, how can I send a way to, I'm looking for the, oops, how to, really don't
Chat.
Yep, I need to chat. How can I find the?
There's nothing in there. There you go.
Nope, that's not the. How can I make the? How can I make the? There you go. Thanks. Let me. Hang on. Let me. Is anyone? I think everyone's muted at the moment. Right. So Well, there are a lot of chats in there, but while I'm getting through these chat, we'll take one question from the audience first. Mando?
Thank you sir, for such an entertaining talk. I agree with most of what you said, but I'll challenge the quality versus the quantity, which was based on evidence section. But I wonder if the quality is really decreasing. Definitely this, because of quantity, you find a lot of rubbish out there. But I would say that in top journals, top medical journals, the comparison between what you see in the 90s and nowadays is, there's a huge evolution in terms of methodology, what's being used, even in terms of the statistical methods available. I'm thinking that one of the common issues or common techniques looking at survival time, finding great model was developed in 2000, right? So this will not even be available. So there was a lot of issues with and so on. So I challenge the top journals, the quality.
Okay.
And also, my impression is that journals like New England circulation, all the circulation journals, Lancet, they all have it's not statistically reviewed. They have a statistical team in their editorial office. So we're also moving in a good direction, at least at the top of the pipeline.
Yeah, although
can you summarize
I've been challenged on whether quality is actually rightly challenged on whether quality is actually declining, and that the top medical journals do it better. Look, I'd say you do. Yeah, okay. Some of the top journals do better for sure. You get better. I think you get better reviews on average. And yeah, you're right. Methods have developed, but they're not perfect. I think if you look at Ben Goldacre's work on outcome switching, that one I talked about, a lot of the top journals are still not catching that. So, yes.
Some of the decisions on capture the errors as well, but still, I think we're building that.
Yeah. But no, look, I do take your point. Yeah.
There's a question from Benoit asking about where's Benoit? About researcher who publish more than 20 papers per year. Whether you think it's possible, and what is your opinion on this? Well, researcher to publish so much.
Yeah, that's a difficult one. It's a potential sign. So somebody's publishing 20 papers a year. It's a potential sign that they're not really doing much. But then I do know some really good people who do publish more than 20 papers a year, and people who are very happy to work with them because a day of their work on that paper, because they're so experienced and smart, actually makes a big difference to the paper. So I think it is possible, but it's a potential worrying sign. Yeah.
Okay. Do we have another questions in the audience? Michael at the back.
Thanks very much for your talk, Adrian. I can't get your dark statistics graph out of my mind. Right, where you've got that strange Histogram Z-score thing.
Yeah.
I mean, it is an odd histogram, but I'm trying to think, what really would you expect to see there under some sort of ideal conditions, sort of, given the current publishing sort of paradigm. And then I guess that sort of hypothesized nice sort of bell-shaped one might be what you would see under a better publishing paradigm. But what would you really expect to see there? I'm sort of...
Okay. So yeah, we're looking at the histogram. What should it look like? Yeah. So we did, in our paper, we did publish, somebody just did a sort of, we did try and replicate what it would look like. I think in reality, you wouldn't expect it to be perfectly normal because people are selecting decent hypotheses. So there's some filtering that's good. I think what really worries me about it is it shouldn't be that sharp. It shouldn't be like a cliff like that. That's if some selection, some non-normality, but way smoother than that. It's the sharpness that's, that you can just see. I think at that positive end, I think it's about 90,000 studies that are within sort of 0.001 to 0.01, just above the 1 threshold. And that is just bonkers. Nick?
Aren't those precipices plus or minus 1.96?
Yes, yeah, exactly, yeah. The precipice is a 1 plus or minus 1.96, yeah.
Answer your question.
All right.
Well, yeah, but people are. Yeah. But people are choosing those values. They're not those Z values are not done based on a good scientific study. They're done based on fiddling the numbers until you got a Z value that was pleasing.
So there's nothing surprising there.
Aren't you surprised how bad that is? I was a bit okay. It's maybe it's not surprising. You're older and more cynical. It still surprised me how steep those fangs are.
Okay, so next question is from Ben.
Hey, Adrian, good talk. Enjoyed it. As someone who's worked in a stats unit in a hospital before, I can certainly attest to the amount of, frankly, pointless research that goes on because medical students feel like they have to do it to be competitive. And you mentioned that you were working with ecologists to try and reduce this kind of pointless and crappy research. And I was wondering if you could explain a bit more about what you're trying to do and maybe how you're going about it.
Yeah, so we're trying to get them to change their criteria and their guidelines, basically, about what taking part in research means. Because at the moment, a lot of them have these guidelines where, yeah, you have to lead it. It has to be published. Can we get them to actually do some sort of quality guideline on whether it was good work? Can we get them to change their ideas about you don't have to lead research? You know, none of us would go and do brain surgery straight off the bat. You know, you go and you build up to it. But there's a sort of hubris amongst some of them, I would say, that they think this stuff is easy and they just go charging in there.
Okay, got next
Good
question.
luck.
Bowen, you still here?
Yes, but thanks, Adrian, for the interesting talk. I'm looking at this forest plot in the research on degrees of freedom, and I was wondering, why do some of those techniques, especially the Dichte process, Bayesian clustering, have apparently no credible interval, confidence interval, whatever they should be?
Yeah, I don't know.
But probably it is because of the methods. I wonder whether you would take a question on that or just tell me, go and read the paper and the methods I use.
Yeah, no, look, Bowen, yeah, that is really interesting, isn't it? Yeah, it's not just the difference in the means. The difference in the intervals are startling, aren't they? Yeah. How the hell did they manage to get, it was a pretty big data set, but yeah, no, that does seem suspicious. I did read the paper, I can't remember.
But the one with the two with the largest odds ratio are probably both non-significant. That's why the DHD really stands out. It's like the third largest odds ratio and so precise.
Yeah, and I've just noticed, like, even that one, look, this is happening again. Even that second highest odds ratio, the lower limit is just above 1.
Yeah.
It's like somebody's put a sort of magnet on 1 and things just repel from 1. Good cyber. Everybody like that cyber.
Yes. Perhaps it was also a Bayesian analysis with a repellent prior on 1, ratio 1. I don't know. Shouldn't make these comments. No. Thanks for that.
Okay.
We'll take any question from the audience in front of me.
Edwin.
The first slide you show about the quantity and quality, because I think at least in Australia with NHMRC that's familiar with, it seems that there's incentive to always publish more, even like in this, when you go for this fellowship and stuff like that, and you see over the years that the number of people who awarded, number of publications just
the publication they're going up and up and up.
And some 15, 20 publications.
Yeah.
Less than 5 years PhD both. And it seems that there's incentive to publish more, and there's no like a demand to not publish, but to publish more. There's no like. Yeah.
It's become hyper competitive, and the thresholds are just.
Like an index that we can use.
most of the indexes I think are terrible, like the university ranking systems. You know, you can't boil down researchers to a number. So there was some interesting stuff. Well, now, I mean, I'm just doing an HMRC application now. You know, you're only allowed to put your top 5 papers in. So stuff like that is actually much better. That was actually suggested a long while ago, only put in 5 publications. And I heard, so I can't say this is true or not, but I was told that it was strongly opposed by the G08, because that is a great leveler. If all these researchers are only allowed to put in 5 publications, it's a great leveler. And the G08 don't like that, because the G08, let's face it, they're also quantity producers. You know, you look at their websites, they talk about the money, they talk about the papers, they talk about their rankings. There's so few. You go to any Australian university website, none of them lead with quality or what we've done to improve people's lives. It's all how brilliant we are and how much money we get.
We'll take questions in the audience first before we get back to you. This question is, what can be done to improve clinical guidelines that have been tainted by nasty stats crimes?
Oh, look, that's very difficult. I think, yeah, if there's a guideline that's been, so I'm taking this question to mean that there's a clinical guideline that's been based on a poor quality study. Yeah. Once these things are in there, it is hard to get them out. Oh, sorry, Jade, it isn't. Sorry, go on then, Jade.
Hi. Yeah. There are some very, very shocking, like not just questionable, but fraudulent, but taken through the courts kinds of research that's still informing clinical guidelines to this day. What can we do about that? If catching them out and bringing it into the public eye doesn't do anything, what can be done?
Yeah. I don't know. I mean, I've just thought of it, but one thing might be if all these clinical guidelines at least were very clear on what work went into it, then that work could be regularly scanned. And if a paper was retracted, the people could be, the people who wrote the guidelines could be told. Because I think at the moment and I think it's people like Andrew Gray from New Zealand have done some work on this. Yeah, it's all their footwork, and they're trying to get these guidelines changed and point out these problems. But yeah, I know he's spent a lot of time and effort trying to do that. It's not an easy process sometimes.
Yeah, because even when like the NHMRC knows, but even they don't know what to do.
Right.
Yeah.
Yeah, there's a bit of an inertia, isn't there? Once something's there and written in a guideline, there's this kind of inertia to change it, which is why, you know, prevention is better than cure, isn't it? You stop it getting in there in the first place. Sorry, Jade, that's not a great answer.
No worries. Thank you.
There's a question at the back of the audience.
Yeah, so you would think that when there's so much quantity being produced, the most selective journals that reject 98% or more submissions could afford to be extremely picky and just take the ones that don't have the errors. What do you think is happening? Why do you think they're not doing that? And do you think that a journal that tried to be extremely selective on these quality issues only could compete and would ever have the same prestige as flashy journals?
Thanks, Amin. That's a great question. So Samin's saying, you know, the top journals could afford to be more selective because there's no shortage of papers out there for them. So yeah, and they reject 98%. Wow, who rejects 98%? Like Nature in that, do they?
I don't know for sure.
But it's huge. Okay, yeah. Some of the top journals reject most stuff. Yeah. Why aren't they more selective, and why are they not having these problems? Because the top journals are still having stuff retracted, often quite embarrassing stuff. I think it's because they're selecting based on interest, isn't it? Not sometimes the interest outweighs the science. And I don't think some of these top journals, correct me if I'm wrong, the registered reports haven't been a big take up there, because registered reports, as we've seen, often produce something that's a bit dull. So they don't want dull. They want the headlines.
Seems like you could have it all if you're picking just the very cream of the crop. You could have just
Yeah, you could. Yeah, no, I think you're right. Yeah, you could have it all. You could have exciting results that were well done. And yeah, I do remember, I won't mention the journal, but it's, you know, I was almost going to mention an impact factor then. Oh my God. It was a very prestigious journal. And I was talking to them about they were going to add in data sharing statements, but they were worried that people would go elsewhere. And this was one of the top journals. So yeah, if you do become too hard and too selective, you might scare away your business. So it couldn't be a bad business model, which is terrible, isn't it?
Carl, you have a question?
Don't you think that one of the problems, like, I don't want to be too cynical and sorry to see also something that can happen without importance, like, but one of the problems is peer review, because like peer review is becoming a full-time job where we receive a lot of papers and sometimes we don't have enough time. In particular, there are some areas where they work mostly with conference proceedings. You can receive like 6 papers to review in 2 weeks. And of course, you cannot be so picky, and you can understand overall if some papers are not statistically sound, but like sometimes you miss something. But do you have any opinion about that?
Yeah, so the question is about, there's just this, you could spend your time, we could all spend our time in this room just doing stats reviews, couldn't we, for the next year? That would be a full-time job for us, and we probably wouldn't scratch the surface, would we? So yeah, that's depressing, but that's kind of why I think I'm leaning towards automation, because when I do a stats review, so I have a little notepad, it's on my desk, it's called Review, because there are certain papers like Sander Greenland's paper on don't dichotomize continuous predictors that I have sent to people over 100 times. And the same one, Thomas Lumley's paper on, the normality distribution. It doesn't have to be normal, don't worry. So I do find myself repeating things over and over again because people have these very wrong ideas. So maybe I could be replaced by a robot. I do feel that sometimes. Parts of me could be replaced by a robot.
All right, we'll take last question from Gordana.
I was just wondering if you could share your overall great paper.
Oh yeah, I'll share that, Paula. Yeah. Next time I do a review, because it'll be the same. I'll just send it to you because this is the same statistical review for every paper. I actually, it wouldn't be a full-time job for me to review every paper. I just have the same. I just do the same one. Hey, you guys are cut and pasting your stats method sections. I'm going to cut and paste my stats review section. That's fair, yeah.
All right, I think this is past 7 p.m. right now, so I think that's all the time we have today. And thank you everyone for joining us on the internet. I can see the people from Western Australia and everywhere joining us. That's good to see. And also, I'm also very excited to see all the members joining us for this face-to-face event, first time for a very long time. So thank you for joining us this evening, and please join us and thank you, Adrian, for extremely insightful talk.